Hello guys, welcome to Math2Go. Today we are looking into sequences of numbers again, and in this specific task we have the nth root of n, and n tends to infinity. So our goal is to identify the limit of the sequence. And before we do so, we need to do some preparations here. So preparation. And what's very good about this is that the preparation is not only useful for this specific task, but also for other similar sequences. So, first point. This is really useful and could be even another separate task you could face is we look into the limit where n tends to infinity of ln x, so the logarithm of x divided by x. And here we can apply L'Hopital's rule. And if you are not familiar with this rule, you can watch one of my other videos where we already talked about this. And then we know that we can just calculate the derivatives of the numerator and the denominator and consider the limit of this new sequence, which is 1 over x divided by 1. And here we quickly see that the limit is just 0. And I just saw I have done a mistake here. It's x tends to infinity. So let me take this and fix it. So x tends to infinity. Similar here for the other ones. X tends to infinity, and then 1 over x becomes 0. Okay, this is the first preparation. The second one is just an observation, namely if a function f is continuous at some x0, then we know something very useful, very useful, namely the limit where x tends to x0 of f of x is the same as if we determine the limit first and then evaluate the function on this limit. So again, x tends to x0 of x, and this obviously is equal to f of x0. So we can, if f is continuous, everywhere continuous, or more specifically continuous at x0, then we can switch function evaluation and limits consideration. We can switch them. This is what is being done here. Very useful fact. And the third fact is something which might be already known to you, but I will write it down here. So a to the power of b equals e to the power of a times logarithm of b. So this is something which always holds, and we will use it here for this task. So keep in mind that this is true. You can look it up in some documentation or try to prove this by your own, or check it for a few numbers whether this is really true. So then to our task. Coming back to it, limit of n to infinity of nth root of n is the same as if we consider it the limit and just rewrite this nth root of n to n to the power of 1 over n. And now we can apply the third observation, the third part of our preparation. And then we know that the limit of then this is the same as the limit of n tends to infinity of e to the power of 1 over n times logarithm of n. And now we can apply the second fact. So we can switch function evaluation and limit consideration, limit and the e function, which is everywhere continuous. So we have e to the power of limit of n to infinity of 1 over n times logarithm of n. And this we already have calculated in step 1. From step 1 we know that the limit of this sequence is exactly 0. So we have e to the power of 0, which is just 1. So this means by using all the preparations we did before, we know that the limit of n root of n, where n tends to infinity, is just 1. So I hope this video was really useful to you. If you learned anything out of it, please comment and subscribe. Like the video and stay tuned for more videos like this.